Let's make a simple adjustment in Fitteia. The line we are fitting has a slope g over k and intercept d naught as shown in example from the introduction video of Fitteia module. As you can see, all fitting parameters are initially set 1 and also fixed. In this situation, if we press fit button, we would simply draw a line with slope and intercept of 1. Since the line is not visible in graph, let's change d naught and g to 0.01 and press the fit button. Yes, and fit. I will take this chance to show that you can return to initial setting by using back button on your browser. However, note that the graph will not update, only the parameter get updated. So if I press back and back, then again the return the initial situation, but the image has not updated. To update the image, I need to press fit or plot. Up until now, we have only been doing plots because fix or parameter is equivalent to the simple slope. To perform an actual fit, we need to release these parameter, but if my plot is g over k, I cannot release both g and k at the same time. I wrote this model this way because in principle I know one of these parameter. In case of g is gravitational acceleration, so I will keep fixed at 9.8. Release d naught and k and fit the line with slope g over k and intercept g naught to this point. Up until now, we can see the fitting line is a straight line and it takes less than 3 seconds. However, if we want to fit more complex models, it's often crucial to know the magnitude of the parameters and give them an initial value from this column to start the adjustment. We can also enter minimum and maximum suitable values in these boxes, but be sure to fill in both. Never provide only minimum without maximum. These avoid getting results that numerically possible but lacks physical significance. Additionally, restricting the parameters to a trigger range from speed up the fitting process. Of course, these gains are also noticeable if this model is very complex. But imagine, for example, there you are trying to find a friend who tells you they are at Technico. This is a difficult from saying they are somewhere in Lisbon. If they are telling you they are at Technico, you are unlikely to look from the Cais do Sadara. This increases your chances to find them while also reducing the time it needed to locate them. The way fitting is developed also show us to very easy explore how sensitive the fitting to the parameter variation. For example, if you curious whether it make a different use 9.8 or 10, you don't have to just wonder. You can change the value g and return fit, see how much constant k increase, and it might be that uncertainty calculated by the program is understand if the k varies significantly with the small change in g. You could also simulate different scenario. For instance, if we perform the experiment on the moon, where would we expected the line to be on the graph? If we perform this experiment on the moon, then the value of g will be 1.6 and plot to see the expected result. You will have your own question and other aspect you want to explore and see you in the next video. Okay.